Welcome, everyone. We're glad to have you. We're super excited to have our speaker tonight. So my house is on Bitly tonight. That's always awesome. That's where I work. We are hiring right now, currently. Also, in quick news, we have started recording these, live streaming them. So if you can't make them, we have a Twitch channel. All done by our wonderful Jason over here. And everything managed from a distance is Stacy in the back. Woohoo! I'm the So, any one of us, if you have questions, want to talk to us, everything on. Jason, I think you had a couple things.
Yeah, so I help organize the Gopher Meetup. Next month, we have the guest speaker that was here last month, Mike Vidal. He's going to give his talk about the 39th Crusade coming last month. So if you missed that, you can catch it in Boulder, but you can also catch it. It's going to be on YouTube and on the live stream. Subscribe to the YouTube channel. If we get 43 more people subscribe to the YouTube channel, I can name the YouTube channel.
Okay, so everyone, stop what you're doing right now. Pull out your phones. Not even joking. Pull out your phones. We're all going to have a group ceremony of subscribing on YouTube. This is how you do it.
Yeah, that's what you get. So you have to search for it. It doesn't have a name. Because every time you have subscribers before I can name it. It is, but I can't name it because we don't have enough subscribers. So that's why you guys are subscribing.
Google hasn't made it very hard for new channels, all right? That's all I'm saying.
So just Google for Mile High Gophers YouTube, and it's the first thing that shows up.
So, there should be roughly 43 people. All right, in other news, we also have the women who go here tonight, and Heather who organizes that, and Stacy. So, for all the women here, we're super excited to have you. Normally I give you announcements to go sync with Heather, so you guys are here, hang out, go talk with Heather and Stacy about all that. With all that, I'm going to just get out of the way and let him take over. You guys ready?
Aye.
Get better.
What's it at now? 74.
I'm busy kind of trying to subscribe here, you know.
Your screen disappeared.
Yeah, I know. I don't know what's the story here. Did I hit? There we go.
Or did the projector go off?
I think the projector went off.
The microphone seems a little bit. Oh yeah.
Did it really just die on us? They said we had an hour time limit for this.
That was not an hour.
That was not an hour, that was like 10 minutes.
So how's everybody doing tonight? Good? Come on! Wouldn't be a real life demo if there weren't technical difficulties. Well, let me at least get started with talking to you guys about who I am. So, my name's Derek Bassett. I'm a senior software engineer for SendGrid, now a business unit of Twilio. I've worked professionally as a software developer for about 20 years. And I've worked on containers, Docker, and Kubernetes for about 3 years. What do we got? Do we got anything?
It's booting.
It's booting.
You said it's green. We're going to get something.
Yay.
I don't know how long you've got, so.
All right, I'll try and keep it moving.
Maybe about 20 seconds.
Oh, that's no good.
Worst case scenario, we'll go grab a TV or something.
Yeah, no worries. So the... Yay! See, and since I'm talking about containers, I have to do the perfunctory picture of containers here. So that's who I am. That's my Twitter handle, Derek Bassett, @DerekBassett. And then down the bottom there is a bit.ly link that if you guys want to follow along with the demo that I'm actually going to be doing tonight, you can absolutely go there and see all the code and everything explained and kind of broken down so that you can follow along with it. So I want everybody's hands up. One hand, two hand, I don't care. A hand up. All right? We're going to level set here. Okay? First question. Who here has never heard of what a container is? If you have never heard of what a container is, put your hands down. Keep your hands up if you've heard of a container. Second question. Who has never used a container before? Anybody? Who doesn't know what Go is? All right, Gopher Meetup. I thought that would happen. And who's never written any Go? All right, great. So everybody's got your hands up. If anything goes south, we all know who to blame. But I wanted to start off by thanking Julian Friedman, Liz Rice, and Wellington Silva. All of them have built various versions of this demo and talk. And a lot of these things I've taken from a lot of the different presentations. Some of the things I've liked about different presentations and tried to kind of bring them all together. So, all right. But the first thing I wanted to cover is, what is a container? And for a lot of the stuff, I'm sure a lot of this is review for you guys. So Docker is a container is a standard unit of software, packages up code and all its dependencies so an application runs quickly and reliably from one computing environment to another. Docker container image is lightweight, standalone, and an executable package of software that includes everything you need to run application. Code, runtime, system tools, system libraries, and setting. So, key features: lightweight, standalone, and isolated. And that isolation is really critical because if you don't have the isolation, you really don't have a container. So what's Go? Well, according to Google, Go is an open source programming language that makes it easy to build simple, reliable, and efficient software. It's a compiled language, provides garbage collection, it has built-in testing and profiling framework, it has an incredibly complete standard library. And the learning curve for Go is really where it shines. You can learn all of Go language features in one evening. Really, I mean it. And just as a personal story for me, I got started really doing computer programming and compiling programming on C back in the 80s when I picked up a $15 C compiler for that. And so, to me, Go is very much going back to that kind of C root and understanding how the technology works at the low level. So that's why I love it. So to follow along, if anybody wants to do this, there's a bit.ly link that I have up there that points at a repository that I'm going to do all of this demonstration based off of. You're going to need Git, you're going to need Vagrant, and you're going to need a virtual box. And the reason why you need these things is because a lot of the features that you use inside of Docker are based off of Linux capabilities. So I'm going to cover these two basic Linux capabilities. The first one is a Linux namespace. Linux namespace, not to be confused with other kinds of namespaces, is a feature of the Linux kernel that partitions kernel resources such that one set of processes sees one set of resources while another set of processes sees a different set of resources. And a C group. The Linux C group is a Linux kernel feature that limits the amounts for and isolates the resource usage. CPU, memory, disk I/O, networking, a lot of different things. All a collection of processes. And what I think is so interesting about this is no one set out to say, hey, I want to create Docker. In a lot of ways, the Linux community kind of built it up over time as they realized they needed more features for it. That's the part that I think is so cool about Docker containers. So, let's go ahead and launch the demo. Give me a second. Mirroring. All right. Let's try this. Technical difficulties. Just a second. Any idea how to get it so that it doesn't mirror? Yeah.
Go arrangements,
Got it.
and then disable. Oh, it should be
Mirror display.
Oh, you
All
want it to.
right. Yay. Excellent. Thank you. Great. All right. Can everybody read the thing, or do I need to make it larger? A little bit bigger? I can do that. Hope you guys don't mind. I'm going to use some cheat sheets here. All right, so the first thing that we want to do is we want to launch Vagrant. And Vagrant's really important because you have to be able to get into a Linux kernel or Linux system. So, as you can see here, the Vagrant box is defined inside of the repository. So if you just go in and run a Vagrant up inside of that thing, you're going to go through, and basically what it's going to provide for you is it's going to install the latest. Latest in this particular case is 1.11 because I didn't want 2 days before the demo to be upgrading to the latest version of Go 112. Untarred root file system of Ubuntu. And it is another copy of a root file system of Ubuntu, which I'm going to show you in just a second. So to go ahead and start it up, you just do a Vagrant up. And now once that's done, launch it. And then what we're going to do, because it works better if you're running as root, we're going to go ahead and run as root here. Okay, and so the first thing I'm going to show you is I'm going to show you my basic program. For those of you who are fairly familiar with Go, this should be pretty straightforward. You should be pretty familiar with what this thing does, but let me just break it down for those of you who aren't as familiar with it. This is a main program. It has a series of command line arguments that get passed in. The intent here I wanted to do was I actually wanted to make it look like a Docker command that you would run on the command line, so Docker run. And so as you can see here, you run something like go run, main go, run, new name dash A. And so basically what this is going to do is this is going to execute the command.
Yeah.
Is that better?
Yeah.
All right. Sorry, guys.
There we go. Is that better?
Yeah.
Oh, see?
Is our switch user happy? Okay, good. Okay.
All right.
Surprise lighting.
No worries. Should have gone for a white color, light color rather than a dark color. So, but basically what this is going to do is this is going to run a uname command inside of our container. I use that as quotes because at this point it's not really that much of anything. All it is just a simple executable that gets launched. It tells you what PID it's actually running under. It goes ahead and tells you, it basically connects the standard outs and standard ins and standard error into the standard out, standard in, and standard error of the OS. And then it just says, hey, you have to run this thing. So as you can see, it's actually producing the format, or basically the exact same data that I would expect if I actually ran the command directly. And so what we want to do is we actually want to make it so that we can be able to see what it looks like when we run it with a bin bash. So that's like running it as a shell. So as you can see, I've got a process running in here. And so the first thing I'm going to do is to try and isolate something like the host name. And so what I'm going to do is I'm going to say host name, and we see it's this Ubuntu Xenial. And I'm going to do host name demo. And if you look at host name, you see I've changed the host name inside to demo, which is great, except that when I exit out of my container and I'm now back into the node, I have a problem. I've changed the host name of my outside node, which is kind of the whole point of container isolation. Let's go back and fix that. All right, so let's go add in some code inside of here. Yeah. There is a bit.ly link. Yeah, so the bit.ly link is under, it's bit.ly 2B5FBQQ, capital Q, here. Down at the bottom. Yep.
He's been in this business for 20 years.
Yeah. Gotta have the right casing. Absolutely. So what we're going to do is we're going to add in a sysproc call. So the clone flags are used to pass into the command to tell it the certain set of commands that are basically executed when you actually execute the actual command. So in this case, bin bash or in the uname command. And what we're going to do is we're going to throw in here syscall And while I'm doing this, I'm going to go ahead, and so that we don't get all the red messages, I'm going to tell Goland not to worry about it. So what I'm going to do here, okay, so we're back to the same host name, and we're going to go ahead and run this command again. All right. Now I'm going to change it to hostname demo. And we see that we change it inside of our container. And I exit out. And everything's gone right. We see that we've now made it so that we've isolated the host name. So that if I change the host name inside the container, it doesn't change outside the outside running process. All right? So the next step we're going to do is we're going to talk about PS. Because right now, what we see is we see that we're running on process 2255, which is a part of the overall the Vagrant's operating system or system set. And so what we're going to do is we're going to add in a new flag, syscall clone new PID. And all we need to do is just that command. Oh, interesting. Okay, the PID didn't change. And the reason why the PID didn't change is because we have to actually do a fork and exec. We have to start a new process up in order for that particular flag to work. And so to do that, what we're going to do is we're actually going to make a different function here. And we're going to call it child. We're going to add it into this case right here. We're going to keep these functions in here. We're going to drop this because this doesn't provide us a lot of value. But what we're going to do is we're going to add in a call to, I want to make sure I get this right. It is proc self-exec. And then what we're going to do is we're going to put self-exec. Oh, right. Thank you. Exec. That's right. Then what we're going to do is we're going to say append. We're going to throw in a new string. Child. And then what we're going to do is we're going to pull out these args 2, that, and that. What am I doing wrong? Perfect. So that does our fork exec, which is exactly what we want there. And then the other thing that we're going to do is this is going to list our process. We don't need to change this. We don't need the proc attributes at this point to clone things because we've already set the new network Unix timeshare, which is what that system call right here is standing for. We don't need to do the clone new PID. And so if everything's done right, we've got all our dependencies. Okay. There we go. We are now an independent, unique PID starting at PID 1, which means all the processes that are created after this point will always have a number greater than 1. It's like you've got an entire self-enclosed process space dedicated for you, which is something that you have with Docker. So, but if we do this, the only problem is now we can still see other processes out of there. And the reason is quite simple. The reason is because PS actually gets its data from /proc. And it doesn't get itself from the process or any sort of kernel information other than the /proc directory. So in order to be able to support that, what we want to do is we want to add in a couple of different things. The first thing we're going to do is include it in your Vagrant box that you guys will be able to demo and practice with. I've created root fs Ubuntu directory. And it's just another copy of Ubuntu separate from the one that you would find under root. And you can tell that because it has imcontainer.fs, root.fs file created inside of there. So what we're going to do is this. We're going to add in a couple commands. There's a must syscall set hostname. And the reason why I'm doing this is because, make sure I got it spelled right. Excellent. The reason why I'm doing this is so that when we actually run inside the container, much like our PID1, we'll have an immediate kind of feedback as to, hey, we're actually inside of our container right now. The next thing I'm going to do, I'm going to add in a must to change root. We're going to change our root directory to root.fs Ubuntu, where that extra copy of the Ubuntu file system actually lives in. And then what we're going to do is we're going to add in a change dir. And then the last thing we're going to do to be able to support proc is we're going to go ahead and we're going to do another syscall. And we're going to mount proc 0 and quote. I'm sure you're wondering, what does this mean? Why do I have to put proc 3 times? And the reason is because it's specifying our source, our target, and our file system. So, all right. Oh, but if we do that, the most important thing that we need to do after that is we need to make sure that we clean up after ourselves for that. And so I'm going to run this defer function that's going to get executed once the method actually gets finished, it returns. And basically what I'm going to do is I'm going to throw in another mus system call, mount, proc, and 0. So now if everything's going right, what's that? Why is that going in that defer function? Why the, yeah, no, so the reason why I put that in a defer function is because the must, I mean, I could have thrown that into the actual defer. I could have said defer must syscall, but I just thought it would be easier to wrap it. What's that? All right.
It would cause it to unmount right away based on the way you go evaluate targets.
Yeah. Thank you. Oh. Let's try this. Nobody caught me. Come on, guys. All right, so now we're running in the root container, as you can see. And now if I've successfully implemented everything and got it to actually work, we should now see that my container is actually isolated in terms of my process, my container from scratch. I have 1, 2, 3 processes that I can actually see running inside of my container. I can't see any of the other processes that are running on my laptop right here with this. And so I've really kind of succeeded with this particular point. So the one thing I would also throw out to you guys here is there's actually kind of a little bit of a gotcha here that I'm going to talk about with this. So at this point you're thinking, oh, okay, I've got an isolated process, everything is good. But go check out a gist that I include in the README that talks about how environment variables can actually be exposed to the host container if you get the chance. So, and I wanted to also show, if we took a look at the slash directory, you can see we're back at I am container root fs. All right, so the next thing I wanted to talk about is the overlay file system. I don't know if people are familiar with the overlay file system, but the overlay file system is actually a part of what really makes the Docker magic really possible, versus making it so that you would have to have a file system of everything. The reason why I say that is because right now, this root file system, this Ubuntu root file system, if I changed it, if I made a directory here, make a file like this, if I had other people who were actually using the same root file system, they would see that change. And that's kind of exposing the isolation that we really want to create here with the Docker container. We want to make it so that everybody can use a copy of Ubuntu, and you don't have to have 15 or 20 or 30 different copies of doing that. And so the way that works is you actually use the overlay file system. So here's how we're going to do that. I'm going to demonstrate that. So we're going to create a couple of directories here. Base, diff, overlay, and working dir. And what I'm going to do is I'm going to actually touch one of the directories inside of here. I'm going to say, okay, we've got a my base file, if I can spell. And then if I look at that file, or if I look at the directory, the base directory, I can see that it's created the my base directory. So then what I'm going to do is I'm going to mount, using the file system here, working dir equals working dir, and overlay, overlay. So source and target. So basically what this command's going to do is it's going to create an overlay mount. That's the type of the file system that we're actually using here. That's what Docker uses under the hood. It's got a lower directory, and so the way that the overlay file system works is something called branches. Branches are basically a series of lower directories that it wants to basically stack on top of each other to kind of give you a full perspective of what the actual system works like. Now, if you've used Docker a lot, you know those as layers, and you're familiar with those particular things. And so basically what happens is that the upper directory becomes sort of the directory you write into and work on. And then the working directory is used by the overlay file system to be able to support that particular thing. And then overlay is just the directory that I want to mount to. And so if I go into the overlay directory here, I can see now that I've got my base file. And if I go in here and I say my diff file, I can see I've added to the overlay directory. But then if I go back into my base directory, I can see that it doesn't actually exist in my base directory. In fact, the only place it actually exists is in my diff directory. And so every time you create a Docker layer, that's really what you're doing here, is you're just creating another branch and putting all the changes and files on that and persisting that off to be saved and used inside the Docker container.
So if you change that my base file,
So if you change it in the overlay directory, the base file, so if I were to write into it, in theory it would, well, let's see. Great question. No VI, draft, echo, great idea. How can I not have VI? Okay, let's see what we got here. So we got my file. So let's see what the base file looks like. I have a good idea, I know what it is, but let's see if I'm right. Yeah, it's empty, because what's happened is the overlay file system has said, ooh, you're changing a file here. I don't want to change the base file lower directory. I'm going to create a new file in the diff directory, and I bet if we go and look at that, and there it is, my base file with...
It's not empty.
It is not empty, it has my file in it. Make sense? And so with your Docker container, that's how that particular thing works. So we're going to go ahead and unmount that. I'm going to go back up here a little bit. And we're going to do exit out of here. Because the next thing we're going to talk about is we're actually going to talk about C groups. And C groups are really critical in terms of being able to control the resources, network, memory, CPU, all those different features that you have in Docker. If you use Kubernetes, for instance, like I have, one of the things that I have to do is I have to go through sometimes and set resource limits on the Docker, on the Kubernetes pods that I've created. And you can do that with Docker pods, or Docker containers as well in Docker Compose. And so really the key thing is, how do they actually do that? How do they send that message to the operating system? So I'm going to cheat here a little bit. What I'm going to do is I'm going to exit out of this thing, because a lot of this code here is kind of duplicated, or is pretty easy. I'm going to snag it. By the way, for all you guys who are following along inside on the web, I have actually all the different steps and phases through this thing. So if you get lost, or if you can't get it to work for whatever reason, feel free to just hit that next step and try and figure out what went wrong. So. All right. Let it kind of auto magic import. So this is a little function called CG. Basically what it does is it creates some directories. But let me start off real quick and show you guys something else. So the first thing you guys are probably going to want to do is we're going to pull in Docker. install Docker IO. So it's already installed on my machine because I've been prepped for this thing. And if I do a docker run -it Ubuntu, and I do a bin bash, one of the things that's very interesting about this is this looks almost identical to the Go code that I just wrote. The go main, go, run, whatever command. Really the only difference is this -it, which says, okay, I want you to hook up standard out, standard in, and standard error. And then the Ubuntu, which says, hey, this is the image that I want you to use. But otherwise, it looks exactly, or almost exactly, the Go run thing. So we're going to run that. And the reason why we're going to run this is because if you don't run this, these files don't get created. So we're going to go to sys fs cgroups memory. And this is where the magic happens. All of these are different files that control different parameters related to memory. And they also specify what group processes these particular constraints fall under. And if you'll notice here, there's also another file right here, Docker. Docker creates a file, a set of files underneath that basically map to all of the Docker groups constraints, the C groups, for that particular thing. One of the things that's interesting, if I do something like C groups procs, you'll see that the file's empty. And the reason why the file's empty is because I'm not running any Docker containers right now. If I was running a Docker container, that file would actually hold the process number for that Docker container. And so that's how these C groups actually work. And so if you want to constrain something like network constraints, all you have to do is create a set of files that map to that network and define a group to it and define a process to it. So that's what I'm going to show you what we do. So if you look here at this code, we see sys fs cgroups. You've got a join for PIDs, and you're going to make the directory. You're going to have 3 files that you're going to be responsible for creating. You're going to be able to create. So in this particular case, this C group that I'm doing is reducing the number of processes, preventing the number of processes that can be run, spawned outside of my internal container to a certain number. And in this particular case, I'm constraining it to 20. And then I notify on release. And basically what that says is when the process goes away, let me know, hey, don't bother, pull this out of the process group, out of the C group. And then I'm going to set my PID into the C group process. And then what I'm going to do here is I'm going to add on to this guy. And this is pretty critical. Don't do this. Things won't work. And I'm just calling it Scratch because that's the name I've decided to come up with for my particular container that I'm building. And so then all I have to do is I do a go run main.go run bin bash, and I run it. And now this is where having this other container, or having this other terminal up is really useful, because what I can do is I can do a process here. Right now we've got just the process actually running, and I'm going to teach you something teach you about something called a fork bomb. I don't know who here is familiar with a fork bomb. Who has heard of a fork bomb? Oh, good. I see that there are some, but not everybody. Don't ever do this on a computer unless you know what you're doing. On an important computer, thank you. Good clarification. If you want to do it on your own, hey, what you do with the business of your own home is up to you. So, this is just a little bit of shell magic. All right, so I'm going to break it down what it's doing here. what I am doing is I am defining a function in bash. That's what this guy right here is. That colon is a function in bash with the parentheses. And that function is going to launch itself, and it's going to launch another self and put it in the background. And then the last thing I'm doing is I'm actually invoking that function. And if everything's worked right... Oh, what did I get wrong? Oh, semicolon, and this hit me yesterday when I was practicing too. Oh, well. Now, one of the things you guys should start noticing is it's saying, hey, I can't do this. I can't create a new child process. What the heck's going on here? Well, if I go here and I look at my aux-u, you can see that basically what I've done is I've limited myself to a certain number of processes. And right now, all those processes are just kind of sitting and hanging out. And so what that means is that with this container, I can't prevent myself from, I can't impact another process that's running inside this box. I've basically constrained myself that way. And the thing is I can do this with network. I can do this with disk. I can say, hey, if you get to 50 gigs and the machine only has 100 gigs, stop. Don't allow any more data being created outside of that thing so that you break the host machine. So, and there you go. That's a Docker container. So, let me pull up. Where'd you go? There we are. Oh, okay. Cool. Off mirroring. All right. Now that we've finished the demo, what's left? What's missing from selling our containers from scratch? Like Rocket, like Docker, like I was actually talking to a gentleman here who was talking about another system that's somewhat similar to that. Not much, really. All we just need to do is do a lot of error checking and error handling with that. What's very interesting is, if you haven't had a chance to do so, I highly recommend going out and checking out the Moby project. So the Moby project is actually the open source implementation of the Docker container. That's actually the source code and a lot of the different features and pieces that I was able to glean about this in terms of like overlays and stuff like that, how that works, was to actually go into that code and see how it actually does that. You know, the biggest thing is to being able to optimize the Docker files with the overlay system. So I hope you guys enjoyed my talk. And I was hoping to see if there were any questions about the presentation. Anything online? Sure.
When you set up the overlay now, it only had a upper here and lower here. Can you overlay on overlay?
You can. And in fact, actually how that works is you actually put a colon in the lower directory, and you can actually put in multiple directories and things like that on it. That's how Docker does it, actually, is that they have a list of lower directories that they build off of your various layers from.
So do you have to do multiple mounts or something?
Just one mount. And then the lower directory, actually, you specify all those particular things. And what's also interesting with that, too, is they actually do a hack where they actually allow you to do relative versus non-relative paths, because as you can see, if you have a lot of layers, that can actually get to be really big, and the buffer that you're actually passing in gets overflowed. So
that's why there's a layer.
Yep.
Mount gets smaller.
Yep, you got it.
Mount flags up. Very interesting.
Other questions? Yeah. I'm sorry.
Any suggestions for Kubernetes and together with the
I'm sorry. I can't start off by saying this is only my opinion and my experience with working in Kubernetes and Docker. Anything you do in Docker, you can override basically with Kubernetes. And so from that perspective, I tend to put in reasonable, sensible defaults. I'll expose ports, kind of standardized ports and things like that. And then I'll go into Kubernetes and I'll tell it, okay, I need you to do something special because I'm in environment X versus environment Y. And so that's how I tend to do that. In terms of the Docker constraints, there's not really, constraints normally happen on what particular system you're working on. If you're doing a Docker compose, you say, hey, I have certain physical memory limits constraints on that. Or if I'm doing Kubernetes, I'll use something like Helm or just the actual tools to be able to do resource limits there. So. Sure, go for it.
The trend in managing your applications is to deliver infrastructure services. So doing things at like an ingress controller level or at a cluster service level, things like certificate management with controller and cluster is a better pattern for scaling lots of apps on a single cluster than to try and ship a specific solution.
Yeah, lots of cases like port. So like I can build a Docker container to build an open port at a certain counter, and then I've got a console control that I can manage. Why not just open all ports in Docker and then manage it to get a security guy to freak out?
Well,
I'm sorry.
Austin, if I could say that a little bit nicer, the whole point of containers are you can shoot yourself in the foot with a container. It's very easy to do that. The intent you're trying to accomplish with the container is isolation. That was one of the key things that I was bringing up in talking about containers, is you want to isolate. And so you really want to limit those ports going out. I'll give you an example. We had a Java app on the previous company I worked for that had a port for doing performance tuning. So in other words, how well can I, hook up a profiler to be able to monitor this Java app, for instance. And we exposed that as a port, but that's all we exposed. We didn't expose everything on the off chance that I might need a random port there or anything like that. We just explicitly exposed the range of ports that we needed to be exposing there. And I think that's really key to try and force you to think about it as an isolated piece or an isolated component. So.
To be clear, the exposed flag doesn't do anything for ports. I think that's actually semantic sugar. There's no firewalling or prevention ports. That's all just temperature. We usually don't use that.
Do what I'm saying. You're not making
So.
Yeah, all of the port directives in Dockerfile don't do anything for security.
Absolutely.
That's kind of where I come to. That's not good.
But if you want to be able to use the magic capital E flag,
Yeah. The other thing I would throw out to you is this. When people say to me, hey, I'm going to expose a bunch of ports inside of my Kubernetes pod, most of the time it's because they don't know about a particular command that's not very well advertised, and I wish we would talk more about, which is called port forward. Port forward is absolutely critical. If you don't know, if you're using Kubernetes and are not familiar with port-forward, get that way, because it can make your life so much easier in terms of debugging. You basically set up a pod, and you can just you forward a request to your local machine, and it goes directly to the pod on the Kubernetes cluster for you at a specific port.
The other thing I've been really successful with is using names as low as you can in the stack. Like assign a name like HTTPS or SCTP or whatever your service actually is, and just use those names all the way up and let it assign ports as it has those available pool, instead of trying to get wrapped up with like, oh, there's a port collision at some level. Just get away from port numbers all the way up.
Just
as
use
low as possible.
That's where I'm getting to now.
Yeah.
Yeah.
I was having conference calls.
Yeah, that's right. Yeah.
level it up and let it into your management.
I have a love-hate relationship with Kubernetes. I love it because it gives me so much power. I hate it because it gives me so much power. Because on the one hand, it's great for deploying things and making sure that they're stable and they run, and I don't have to worry about them. But it is very easy to overthink it, and I caught myself doing this, especially when we were first starting to learn Kubernetes and starting to use Kubernetes, where I would try and make things too complicated, and after a while I'm just like, oh, well, let's just pull all that away and make it as simple as possible to convey a meaning, and then, all right, maybe I have to use a port forward command, or maybe I have to use a special command to access it, but that's okay. So, telepresence?
Yeah.
I have not.
I highly recommend it. If you use port forwarding, it gets rid of port forwarding entirely.
Oh, wonderful.
It basically explodes Kubernetes DNS to your local.
Oh.
So you can look it up on
Telepresence, you said?
Yeah, it's the same guy that did it. But it-
Nice.
Yeah, it really changed what it was.
Great. Thank you so much. And thank you all for coming tonight. I really appreciate it.
Alright guys, that's all we have planned for you tonight. Feel free to hang out. We're here today. So feel free to hang out. There's 3 left over around people to start. So thanks for all coming, guys.
Thank you for giving me a technical.
That was really good. That was so interesting.